Okay. Goodness me, that was painful. Okay, let's see what we got. What I want to look at today is mathematics and in regards to angles, polygon, heptagons, etc. Okay. Let me just see if I can get him up. Okay, let's see. Okay. Now, let me just run this. Let's look at this. How we go. You sure? Okay. Well, this is teaching material produced by a company, okay, in regards to quality resources for the mathematics classroom, okay, and all they do here is this is just the sell point, basically, okay, but what they've done, they've produced some quite useful material, which I think and hope you will find useful, okay. Here we're looking at interior angles of polygons, okay? Mathematics, interior angles of polygons. Here we have 4 sides, 1, 2, 3, 4. Here we have 5 sides, 1, 2, 3, 4, 5. Here we have 6 sides, 1, 2, 3, 4, 5, 6 sides. And here we have 7 sides, 1, 2, 3, 4, 5, 6, 7 sides, okay? Okay, just make sure that we can get that in place. Okay. This is called a quadrilateral, okay? This is called a pentagon. This is called a hexagon. And this is called a heptagon or septagon, okay? Now let's look at the angles of each of these in turn. And let's look at what the angles actually add up to when they are actually made into a single triangle. Now, when I say single triangle, I'm simply referring to dividing these shapes into their relevant angles, which adds up to 180 degrees. That is what I am referring to, okay? Make sure that you understand that concept and you draw out some of these for yourself so you enlighten your own knowledge and experience of learning. You create your own style of learning, okay? That's what it's about. Okay, let's go. We're starting with the 4-sided quadrilateral first, okay? And here is my marker, my line, okay? And you can see that we have 1, 2 triangles in that shape, okay? That triangle is 180. This triangle is going to be what? What must it be? It's going to be 180. And therefore we have 2 180 degrees triangle in that quadrilateral. Okay? And that equals to 360 degrees. Okay. Here we come to the pentagon. Now, how many triangles do you think we're going to make out of this pentagon? Let's just have a look, shall we? 1, 2. So we have 1, 2, 3 triangles in our pentagon. Okay. I'm just trying to make sure that it's in shape, it's in view. Okay. Now remembering that each of these triangles here has to add up to 180, you can see for start that immediately that these angles here, this pentagon is going to have quite a large number of angles. Let me rephrase that. Not a large number of angles, quite a large number of degrees in regards to the sum total of the, triangles, in regard to the sum total of the triangles that makes up the pentagon. It's okay, I'm trying to find a way of putting it that makes some kind of sense, but you might make better sense of it than I do. Okay, so don't hold me to my words. Okay, but 1, 2, 3 triangles you can see is there without a shadow of a doubt. Okay, now each of these are going to be 180, 180 and 180. Now, so what we have here is 3 180 triangles, adds up to 540 degrees. Okay. Now, next, we come to the hexagon. Now the question here is, how many triangles are we going to have in the hexagon? If we have 2 here, 3 here, how many do you think we're going to have here? Well, let's find out, shall we? 1, 2, 3. 1, 2, 3, 4 triangles in the hexagon. Okay. So we have now 4 180 degrees triangles, 180, 180, 180, 180. That gives us 4 180 degrees triangles, which adds up to, hang on, tell me please before I go any further, tell me you're quite correct, adds up to 720 degrees. And we have the 7-sided figure, heptagon or septagon. How many triangles are we going to get out of this 7-sided figure, or 7-sided shape if you prefer? One, 2, 3, 4. 1, 2, 3, 4, 5. 5 triangles we've gotten out of the heptagon or septagon 7-sided figure, and the total degrees will be 180 plus 180 plus 180 plus 180 plus 180 equals 900 degrees. Okay. Now here we're looking at find the connection between the number of sides and the number of triangles. Now there is a formula here, okay? Right? There is a formula here. Finding the connection between the number of sides and the number of triangles. And I hope they've given it to me, okay? The sum of interior angles of an n-sided polygon is is 180 degrees. Now the formula you need to look at and keep in mind is n open brackets n minus 2 close bracket triangles equals n minus 2 times 180. Now look, I'm just trying to think, is there any other way I can put this or look at it from a different perspective? Okay, maybe not. Okay, n minus 2 triangles equals n minus 2 times 180. Okay, that's the relationship. Now I know this works because I used it earlier myself in some mathematical calculations earlier. Okay, so here we're looking at interior angles of polygons. Calculate the angle sum and interior angles of each of these regular polygons. Well, let's see what it does. Number 1 is 7-sided. 1, 2, 3, 4, 5, 6, 7 sides. Number 2 has 9 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. Number 3 has 10 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Number 4 has 11 sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Number 5 has 12 sides, and so on, 16, 20 sides, etc. Okay, but you can see here it begins to become a little bit more almost difficult to distinguish your marking in regards to the angle shapes. Okay, septagon or heptagon. Okay, nonagon, 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 nonagon. Okay, I like that. Decagon, hendecagon, hendecagon, hendecagon. You might be able to pronounce these better than me with all your teeth. Okay, hendecagon. Dodecagon, dodecagon. Hexadecagon, hexadecagon. I'm sorry, forgive me. I apologize. I have to apologize. I'm sorry. decagon. Okay, and I'm hoping that you can pronounce these better than myself. And last but not least, icosagon. Icosagon. Now, icosagon. Okay. Septagon, heptagon, 900 degrees on 28.6 degrees. Let me just check something here for myself. Okay. Now, this answer here is achieved by dividing this number here by this number here. Okay, let me repeat that. This answer here is achieved by dividing this degrees here, 900 degrees, by 7. That gives you that answer. Okay. And again, the same thing here applies. Okay. Okay, and same thing here applies again. That number here divided by 9 gives you 140. Okay, 140 degrees. Let me be precise, or try to be at least. Okay, 1440 degrees divided by 10 gives you 144 degrees. 1620 degrees divided by 11 gives you 147.3 degrees. That would be for each triangle. And I hope I've got that right from my perspective. I'm not saying I'm correct, but please be sure that you check this for yourself. Make sure that you understand the concepts behind it. Okay. Dodecagon, 1800 degrees divided by 12 give you 150 degrees per triangle, basically. Okay. Hexadecagon, 2520 divided by 157.5. Sorry, my apologies. 2520 degrees divided by 16 gives you 157.5. Okay. Icosagon, 3240 degrees divided by 20 gives you 162. Okay. Now calculate the angle sum and interior angle of each of these regular polygons. Let me see if there's anything else I need to be getting into view. Interior angles of polygons. Okay. Find the unknown angles below. I'm going to leave that for you for a little bit to ponder on. Okay. Find the unknown angles below. Diagrams not drawn accurately, okay? So they're just done rough. Call them freehand drawing, okay? Okay, okay, let's go, okay? Okay, so keeping this in mind, we know that 2 180 equals 360 degrees, and if you remember from earlier, the name of this shape, that I'm going to leave that for you to recall, okay? And we know it adds up to 360. When you add these up together, it gives you 245. So when we take 245 from 360, it leaves us 115. So therefore, W is equal to 115 degrees, okay? Next one. Three times 180 equals 540. We add those up. Gives us 390. We subtract 395. Sorry, it gives us 395. We subtract 395 from 540, leaves us 145 degrees for X. Okay. Here we have Y, and we need to find Y. Okay, we know that this will give us 4 triangles, which equals 720 degrees. We add up all of these here, okay? It gives us 603. 720 minus 603 equals 117 degrees. So we know that Y is 117 degrees, okay? Similar thing here, 900. We add up all these together, okay? We need to find Z, so we subtract 776 from 900, leaves us 124 degrees for Z, okay? Okay, let's just try these for yourself, okay? I won't be doing these for you. These are for you to work out and for you to practice on, okay? Have a go at the others before I continue. Remember that's 90 degrees, okay? That's 90 degrees, okay? Go ahead, try them. Thank you. Okay. Now you've done this already, so you look back at your work, okay? And now try these one for yourself, okay? And thank you. And I hope you found that useful. Have a good day. Bye-bye.